Good morning, everyone.
Good morning. How are you?
I'm good. And yourself?
I'm pretty good.
Good. Ayla, what about you?
I'm okay.
Doing okay? Awesome. Okay, so just to give you an update, since I won't have class, I already told you guys yesterday, since we've got all that stuff going on, we won't have class next Wednesday or Thursday. So what I'll do tomorrow, since I have a lot of time on my hands tomorrow, all those dates all the dates that you've showed up to for class up to now, I'll put in Bright Thinker as extra credit. So just kind of keep an eye on maybe grades changing, and then I'll put a little note that say, because I usually kind of have to spread it out from assignment to assignment. So I'll put a little note that says extra credit points for showing up to class. So kind of keep an eye on that tomorrow, okay?
Okay.
Okay. Any questions on anything so far? Do you guys need help on anything?
No,
Anything
it's been pretty easy so
specific?
far.
I know, right? It kind of like shocks you like unit 6, and then things get a little bit easier, which is kind of nice. So what I thought I would talk about today is solubility, how to read a solubility chart. So when you get to that point, it's a little bit more familiar to you guys. That sound okay? Thumbs up, maybe. Okay, let me share my screen here. Maybe. There we go. Okay, so I just want to talk about a little bit about different types of solutions, and then just some practice on reading solubility charts or solubility curves. So first of all, there are 3 different types of solutions I think this is lesson 4. The first type is called a saturated solution. So again, a solution is when you have a solute dissolved into a solvent, and then those together makes up your solution. So you can have a saturated solution. That means that whatever solvent you have, it has the maximum amount of solute dissolved in it that it could take. As in, if you were to put more solute into a saturated solution, it would not dissolve. It would kind of just drop down to the bottom of the container. So saturated solution is saturated. It is saturated with as much solute as it can possibly handle. And then if you add more, it's not going to dissolve. That's the first type, is saturated. The second type is called an unsaturated solution. So again, it's a solution, but this time you have less solute in the solvent than the solvent could actually dissolve. So it could take more, and it could dissolve more if you added more until it became saturated. So unsaturated solution, more solute could be added to the solvent, and then it will still dissolve. So that's the next one. And then the last one is called and this is one that I find that a lot of people haven't heard about. So a supersaturated solution, it's super, so like more, okay? So it contains more solute than what would normally dissolve in that solvent. Now, the only way you can make a supersaturated solution is you're going to either going to have to change the temperature or the pressure of the solvent to allow it to dissolve more solute. So supersaturated solution is usually going to be made if the solvent is warmed up, and if there's several things that can cause a solute to dissolve quicker or a solvent to be able to dissolve more than it really should. And like changing pressure, changing temperature, agitating it, stirring it, that's all going to help. But with a supersaturated solution, usually what happens is they warm up the solvent, and then you're able to add more solute than it would normally take at room temperature. And it will dissolve it, and you won't see the substance, but it's super unstable. And so if you were to take a crystal and add it to that supersaturated solution, it would actually cause the extra solute to precipitate out, or to make all of these crystals. A lot of times they say it will precipitate out. But it won't unless it's like agitated or changed, or a crystal might be added to it. It's really kind of cool. So I'm going to show you it just a very short video on what a supersaturated solution is going to look like. Okay. Let me see. Stop sharing. Let me change my windows. Okay. So this is supersaturated. That means the solvent is taking more solute than it normally would take. Hold on a second. Let me make sure there's one specific button you have to put so you can hear the sound, and sometimes I forget that. Okay, here we go.
Supersaturated solutions are inherently unstable. If you add a small crystal to this metastable supersaturated solution, bam, crystals start to form throughout the solution. To make a supersaturated solution, we start out with pure water, just H2O. That's our solvent. That's going to dissolve these crystals here. We put the crystals in, they're called the solute, and they dissolve. This is an unsaturated solution since we can keep dissolving more of the solute, more of these crystals. The crystals that we're using here are called sodium acetate, and everything in that beaker, ultimately it's going to dissolve. After a while, no more solute will dissolve at room temperature. Now we say the solution is saturated. But if we heat it up at that new temperature, all of this is going to dissolve. And here's the awesome part. When it cools down, the solute, those crystals, they stay dissolved. We say the solution is now supersaturated. It's holding more solute than it would at this lower temperature. We drop in a seed crystal, or sometimes just touch the glass, and the crystallization process starts. We can heat it up again, then let those crystals dissolve, and as we let it cool down, we'll have our supersaturated solution again. This is Dr. B with Supersaturated Solutions. Thanks for watching.
Kind of cool that you can do that. And there's a lot of little experiments that you can do just like that, if you have the like way to heat up your solution, that sort of thing. So that is a supersaturated solution. Now let's look. Let me share my screen again. Let's look at solubility curves and how to do kind of some of those problems, because those are a little hairy, but not too bad. Okay, so first of all, just a reminder, remember solubility is the ability of something to dissolve in something else. So something could be soluble or insoluble. So for instance, sugar is soluble in water, oil is insoluble in water. So soluble can dissolve, insoluble cannot dissolve. So the picture I have right here, this is called a solubility curve. And on your x-axis, or sorry, on your y-axis, you're always going to have your solute per 100 grams of whatever solvent you're dealing with. In this case, it's water, okay? And then your y-axis, you're usually going to have temperature. 9 times out of 10, you're going to have temperature. So the way you kind of read the solubility chart is if any of the points for that substance, so it could be sodium chloride, it could be potassium chlorate, it could be sodium nitrate, whatever it might be, if the point falls on the line, that means the solution is saturated. If you have any points that fall underneath that curve of that substance, you will have an unsaturated solution. And if you have any points that fall above, okay, the curve for that substance, it's a supersaturated solution. So if you are going over a certain temperature and up a certain amount of solute, like 80 grams, this substance, so let's say if I go over 50 degrees and 80 grams, then my solution for this substance would be supersaturated. In order to have a saturated solution, let's say I go over to 90 degrees and then up, let's say this is 75 grams, and my solution is going to be saturated. And then anything below the curve is going to be an unsaturated solution. So we can actually use this on different substances. And each substance is going to dissolve at a different rate, or you're going to have different amounts of the solute in order for it to dissolve at specific temperatures. So when you see a solubility chart, you guys, you're going to see a whole bunch of lines with a whole bunch of different substances. And so it's just a matter of really looking at the specific line for that specific substance. And then you're always going to go over and then up, just like in math, to find that point. How are we doing? Okay, so are we good so far?
Yeah,
Do I have any questions?
I don't.
Okay. Okay, I will continue. Okay. So if we were to take a look at this, and our options for this question are going to be A, unsaturated solution, B, saturated solution, or C, super saturated solution. So we've got our solubility, our grams of solute on our y-axis, and our temperature in degrees Celsius on our x. As you can see, you've got all these different types of solubility curves because you have all of these different types of substances. And each substance is going to dissolve differently and at a different rate at certain temperatures. So down here it says if we have 80.2 grams of sodium nitrate at 30 degrees, we want to decide, is it a unsaturated, saturated, or supersaturated solution? So I'm going to find sodium nitrate, and it's right up here. It's in pink. Over. Let me see if this will mess it up. Okay, so this is the line that I'm looking at. Okay, so at 30 degrees and 80.2 grams. So if I was to go over 30, up 80.2, so let's see, 80 over 30, up 80, what is it, 80.2? So that's just a little, oh, am I at 30? There we go. So if I go up 80.2, it's going to be right about here, right? Just a little over 80. Oh, what? I don't know what I just did. I just put in a text box and I didn't mean to do that. Okay. So I'm going to get up to 80.2. So that's just a little bit over 80 right here. And so that's going to be, oh, my line just disappeared. So that's going to be under my line, under my solubility curve. So that would be considered an unsaturated solution because it's underneath that line. So now if I go to calcium chloride, so I need to find my curve for calcium chloride, and it's right here. And I'm going to go over 20 degrees and up 75.5. So over 20, up 70. Let's see, 70. This is 70. Oh, where'd it go? 75.5, right? So maybe right about here. So I don't know what's going on. So since it fell directly on the line, that would be considered a saturated solution. I don't know why my lines keep disappearing. So then we're going to find calcium chloride. Here's my line for calcium chloride. And I'm going to go over 50 degrees and up 50 grams. So over 50 degrees and up 50 grams, which will be right about here, right? So since that's above, I don't know what my computer's doing. So since it's above the solubility curve for sodium chloride, that's considered to be a supersaturated solution. So that's how you do those problems, okay? And Bright Thinker will throw several of those at you. You have to decide if it's saturated, unsaturated, or super saturated. I think that really the only kind of confusing thing is there's so many lines. You really kind of have to be like, okay, what substance was I dealing with? What line am I using? So there's that. Let me show you a few more examples that you're going to run into as you're looking at solubility curves. Okay. So this is probably going to be the easiest kind of problem right here. It says, to determine the amount of potassium chlorate needed to create a saturated solution. So if it's a saturated solution, would the point be above the line, on the line, or below the line? Or saturated?
Oh, on the line.
It'd be on the line. Good. So to determine the amount of potassium chlorate needed to create a saturated solution at 30 degrees. So we're going to go over 30 degrees. So this is our potassium chlorate line right here. So we want to go over 30 degrees, and then all we're going to do is we're going to go up until we hit the line, and that's going to tell us 10 grams, okay, of potassium chlorate. I feel like my computer is possessed. I don't know what's going on. So that tells me that in order to get a saturated solution of potassium chlorate at 30 degrees, I have to add 10 grams of potassium chlorate. That one's pretty easy. The next one, so it says the solubility curve can be used to determine temperature. So before we were using it to figure out the amount of solute. So now we're going to look at temperature. So the solubility curve can be used to determine the temperature needed to create a solution. So for example, to dissolve 20 grams of potassium chlorate in 100 milliliters of water, what temperature does the solvent need to be for the entire solute to dissolve? So that means if the entire solute is going to dissolve, it's going to be a saturated solution. So we're looking to land on the line. So it says 20 grams, and we are back to potassium chlorate. So we go up 20 grams, and we're going to go over until we hit the line because it's a saturated solution, because it says what temperature does the solvent need to be for the entire solute to dissolve? that means the solution is saturated. So I'm going to go over until I hit my line for potassium chlorate and go down, and I'm going to approximate. That's going to be about, to me, it looks about 52 to 54 degrees Celsius, right around there. Give me a thumbs up if that makes sense so far. Okay, good. Awesome. Okay, let's do another one that you are gonna find. So, gosh, it converted my writing into text. So it says, let's actually move to the next one. How's that? These are all examples of things you're going to run into. So it says the solubility curve assumes the solvent is in 100 milliliters of water. It says it right here. If a different amount of water were indicated, you could use proportions to solve for the amount of solute. So here you're going to figure out how much solute if you have more than 100 milliliters of water. So it says, let's look at another example. If you want to create a saturated 500 milliliter solution of potassium chlorate at 70 degrees, this is how we're going to go about it. So we're going to go over to the 70 degrees. Now we want a saturated solution, so it's got to fall on the line, right? So I'm going to go over, of course, to 70 degrees. I'm going to go up until I hit the line because they want a saturated solution. And we're going to see that to get a saturated solution at 70 degrees, we need, gosh, what's going on? We need 30 grams of the solution. Draw. There we go. So we need 30 grams of KClO3 in 100 milliliters. But they want to say, okay, so if we have 500 milliliters, how much is going to dissolve at 70 degrees of potassium chlorate? So here, I mean, they make it, I think, a little more complicated. So all you're going to do is multiply it by 5 because it's 5 times more than 100. So that's going to give you the 150 grams if you had 500 milliliters instead of 100. So if they said in 300 milliliters of solution, you would multiply it by 3 and it would be 60 grams. Oh, sorry. Let's do some math right. Let's say 90 grams. So sometimes you're going to have to do that. So if they alter, okay, the amount of solute, you're going to have to multiply it by that number that they increased it by. That's not too bad. And then our last one is finding how much of a solute is going to precipitate out. So it says you can use the solubility curve to determine how many grams of solute will precipitate out of a supersaturated solution. So it says, let's solve for the estimated precipitate of 50 grams of potassium chlorate in the solution using the solubility curve. So we're back to our potassium chlorate right here. It says locate the 50 grams of potassium chlorate. Okay, so we're going to go 50 grams of potassium chlorate, and we're going to go over to our solubility chart. And that is, what is that, 90 something degrees, right? And then it says, let's say it is cooled to 30 degrees. Locate the temperature on the x-axis in relation to the solubility curve, and the value is 10 degrees. So at right up here, 50 grams, okay, at our original temperature. And then if it cools down to 30 degrees, what we're going to do is we're just going to find the difference between the two. So we start with our 50 grams. I don't know what's going on. So we start with our 50 grams. And then as the temperature decreases, okay, still we want a saturated solution. As the temperature decreases, okay, the amount of solute that will dissolve at that temperature is going to decrease as well. So as it cools down, then we're going to have a whole bunch of extra solute precipitate out, and that's just going to be 40 grams. So you're just going to subtract the 50 from the 10, okay, as the temperature changes to give you the 40. That's not too bad. Let's just do one or two other problems together. We only have a few minutes. Okay. So I just have a few. We don't have to do all of them, but let's see if we can kind of do these together. So it says when 20 grams of potassium chlorate is dissolved in 100 milliliters of water at 80 degrees, the solution can be correctly described as, so we're going to describe it as saturated, unsaturated, or supersaturated. So it's 80 degrees, and again, potassium chlorate. So we're looking at this curve right here. So I'm going to go over 80 degrees and up 20 grams, right? Right here. So at that temperature with that much solute, is it saturated, supersaturated, or unsaturated?
Unsaturated.
That is correct. It is unsaturated. It's below the line. Very good. So it says how many grams of sodium chloride are needed to make a saturated solution. So again, we got to fall, our point has to fall in the line in 100 grams of water. Now, just so you know, 100 grams of water is equal to 100 milliliters of water. 1 milliliter is the same as 1 gram. So just FYI. So now we're going to sodium chloride, which is right here. So how many grams of sodium chloride are needed to make a saturated solution at 90 degrees? So I have to go over 90, and I got to go all the way up until I hit that line. And then I'm going to go over, and that's going to tell me going to be approximately 40 grams. And it has to be on the line to make it saturated. It says, at what temperature would 40 grams of potassium chlorate dissolve to make a saturated solution? So we're back to our potassium chlorate right here. So it says how many grams of sodium chloride, oh, sorry, we're down here. At what temperature would 40 grams of potassium chlorate dissolve to make a saturated solution? So now we have to go up 40, and we're back to potassium chlorate. I'm going to erase some of this stuff that I drew on here. Okay. So I'm going to go up 40. We're back to potassium chlorate, and we're dealing with the saturated solution. So what would you guys say right about here? Something like that?
Yeah. What number would that be?
You're gonna kind of have to estimate, but it looks to me, I don't know, like maybe 82, 83, 84-ish. So you kind of have to estimate because we only have 10 points between 80 and 90. So, and you might, if you have a ruler handy, you could put your ruler on your computer, and then that might make it a little easier to estimate. But I mean, would you guys agree maybe 83-ish degrees Celsius if we come all the way down? Maybe 83 or 84.
Mm-hmm.
Something like that. And they'll probably give you some options, so it will narrow it down a little bit. And then our last one, it says how many grams of so we're back to sodium chloride. So we're back to this line right here. Make this quick since we're over. Okay, so how many grams of sodium chloride are needed to make a saturated solution in 400 grams of water? So 400 grams is the same as 400 milliliters at 90 degrees Celsius. So we want to find grams of sodium chloride to make a saturated solution in 400 milliliters at 90 degrees. So I'm going to start over here. I'm going to do 90 degrees. And I'm going to go up and I need to find sodium chloride. It's saturated, so I got to stop on the line. Okay. So approximately how many grams at 90 degrees? Does it look
40
like
something?
40 something? Yeah, I would say approximately 40.
And when you try to get that, when you're going vertical, right? You're not
Yeah.
getting the horizontal one. I
Yeah,
mean,
so
you're doing the horizontal one, not the vertical.
yeah, well, I went horizontal and then I went up to get to my vertical.
Okay.
Because it says how many grams. So we're wondering how many grams, okay, saturated, so it's got to be on the line. So I got to go over to 90 degrees and go up.
Okay.
Okay, so that's where I start. So if I have 100 milliliters of water at 90 degrees, 40 grams of sodium chloride will make a saturated solution. But we're not quite done because it says how many grams of sodium chloride are needed to make a saturated solution in 400 grams of water. So it's 4 times as much as the chart is telling us. So we're going to take 40 and multiply it by what? Any guesses? So we're going to actually multiply it by 4 because we have 4 times the amount of water that is on the chart. So they're saying, okay, we have 400, and again, remember, 400 grams of water is the same as 400 milliliters. So if at 100 milliliters, okay, 40 grams will dissolve. If we multiply that by 4, that tells me at 400 milliliters, we're going to get 160 grams to dissolve and make a saturated solution. Have you guys ever seen anything like that before, or is that brand new? Probably brand new. Okay, I figured that since you probably are not to that place right now, that when you get to that point, okay, seems brand new. Gotcha. So when you get to that point, you guys, just go back to the video in Teams and then you can re-watch it if you have any other questions. Does that sound good? Okay. Okay, cool. So I'm gonna let you go because I know some of you have other classes and so do I. So look for my videos for next week and then I'll see you in 2 weeks' time, I guess. Okay? Take care. Enjoy your weekend.